well. Today I have a very special guest, Azure DevOps MVP Matteo Emili. This is the second time he will be my guest, and hopefully I will not lose my internet connection like last time. Matteo, welcome. How are you?
Hi, Mert. Everything fine from the UK? Well, fine as in COVID fine. And yeah, great to be back. Great talking to you as usual.
Okay, thank you very much. So, um, before we start talking about our topic, can you please introduce yourself?
Yep. I work at Avanade UK as a manager for DevOps engineering and software engineering. I work in the UK and Ireland, but again, part of Avanade, so part of a global company. And what I do is working all day in, day out with Azure, with cloud, with DevOps, and with modern engineering practices.
Okay, guys. So this time I am not going to ask what is DevOps, but instead I am going to ask what is DevSecOps.
Well, you start with a very poor question, I would say, because it's well known that I really don't like the DevSecOps term. If you think about it, we talked about it last time around. DevOps is the union of people, process, and products to continuously deliver value to our users. Now, how is it any different from DevSecOps or DevSec beats test whatever ops? There's no difference because if you're doing DevOps, you can easily embed security as part of your DevOps practice, but you don't need a new name, you don't need a new buzzword. You just need to actually do it and implement the right practices and the right tool into your DevOps practice.
Okay, thank you. So I want to start with this question: how can I secure my CI/CD pipeline?
Well, that's a very good question actually, because
Okay,
when
thank you.
when we actually when we actually talk about security in DevOps, security is always an interesting day, as I like to say. So when we start talking about security in DevOps, everybody just thinks about the CI/CD pipeline, but the CI/CD pipeline is just a portion of the actual story, right? Can you share my screen, please?
Okay,
So this is why I say it's always an interesting day. Security, when it comes to DevOps, starts at the beginning. And the beginning here is our developers, is the development teams, is the actual people working on a project. So if you start working on some code, before you secure the CI/CD pipeline, you definitely need to write secure code. And you need tools for that. You need something that helps you with that. So you have something like, in the four cycles, in the four quadrants, you have something like DevSkim, Key Vault, and SDL principles, which are key to any secure DevOps practice. The reasons are simple, right? So SDL, Secure Development Lifecycle, is an old, well, relatively old methodology, I would say, but it's still valid today. It's something that actually should have even more prevalence because SDL should be applied at scale on any of the products that we work on every day. It's about having security as a first class citizen. It's about making sure that security is not an afterthought. It's not something that happens here at monitoring, but you want to make it happen here from the beginning when our users are going to be defined, where our personas are going to be defined, and when our developers are going to start working on it. And then you have tools like DevSkim, which are going to facilitate writing secure code. Writing secure code is not easy, and nobody's going to ever say that it's easy. But it's very important. And if you fix code afterwards, we'll see that in a minute. But when you start fixing code rather than designing code being secure from the get go, you will have a cost attached to it. And that cost risks becoming unmanageable after a very short while. So having tools in the IDE, DevSkim, SonarLint, there are so many that can help you writing more secure code is key, as well as having connected services like Key Vault that prevent you from using secrets in the wrong way, and they prevent you making mistakes in your CI/CD and enlarge the broader DevOps story. Because at the moment you put a secret in a version control system, like a password, right? A web config file, you have username and password in clear dev. The moment you check that in, then that secret is lost because it will always be available in the history of the code base. So if you use something like Key Vault, we will see how, but it's possible to completely prevent that. And unless you are a Key Vault administrator, so you're actually inputting data into Key Vault, otherwise you have no idea what the secret is. And it's good not knowing what the secret is, because there's going to be a tool that takes care of it for you. Then you have the build process. And in the build process, you need to start looking at something like software composition analysis. So having white source, just to name one, telling you, look, you're using an old version of a library. That library is vulnerable. You have a security problem. Fix it ASAP. Things like SonarQube and Q1 for code quality scans. So knowing that your code is not only secure, as it should be, but it also doesn't expose technical debt that can be used by an attacker. I think about SQL injection. SQL injection is a security problem, but it's always caused by technical debt, because otherwise there is no reason why you should use SQL statements that way. And it's usually taken as a shortcut, which means that your technical debt is going to become your security vulnerability down the line. And then you start looking at tools like static security testing, so bin scheme, Fortify, check marks, stuff that runs against your code base, and it will scan your code base for well-known issues, and those tools will raise these issues for you, knowing that it's been scanned with a modern security engine that checks for the latest vulnerabilities. Tools like SonarQube now, and Q1 as well, in fairness, they started integrating security scanning as well. So those two areas here, code quality and static security, they're very close together because they both act at the code base level. Once you start building out environments, so going towards the deployment side of the story, you need infrastructure as code. Hence, you need infrastructure as code security. And that's where the Secure Kit for Azure comes into play. AZSK will have a scanner, amongst many things, that's going to check for the state of your ARM template, but also for the state of your live environment. And that's going to be extremely important because once you have a live environment, you have no insurance that it's going to be the same as deployed. How many times, especially in non-production environments, we have people, myself included sometimes, that go in there, Azure portal, or let me change this variable because I need to test something, or let me change this configuration because we identified it didn't work. Yeah, we'll do it later with infrastructure as code, but let me check it first to verify that it works. It happens all the time. And having something like this is going to prevent you from making mistakes, because you might actually need to change the environment, or you might actually need to change something in that environment on the fly, but then you can have something that ensures that your environment is secure. Once the environment is secure, dynamic security testing. So your application is live and your application needs to be security tested. Hence tools like OWASP or other offers from Fortify or from Veracode. There are a number of vendors that do that. And eventually, this is very often overlooked, malware scans. So you scan your code. You might scan your code at build process. That's brilliant. But how about scanning the environment on a regular basis? How about making sure that your environment is actually clean? Because more often than not, things are taken for granted and things can happen, might be false positive or anything, but it can happen that you can introduce some dangerous code into your application. So it's good to have a good old malware scan running inside any of these environments, especially if those malware scanners have got an API. That's extremely good because then you can automate the scanning process. Eventually, monitoring. So having continuous monitoring embedded in your platform, having continuous assurance, identifying infrastructure drift. So the problem that I mentioned before, security validation of infrastructure as code and environments, that becomes extremely more important here, because with continuous assurance, you're not going to be able to have drift in your environments. Once your environment is identified as drifted, it's going to be rolled back. So things like that will obviously increase security of your platform. And eventually, this is the last one, but it's also the most difficult one, having proactive mitigation. So you have incidents, you have problems, you have security reports, brilliant. What do you do with them? So actioning the results of these scans, of these incidents, of these known problems is pivotal to make sure that then you keep feeding the loop with more quality and more security. Very long-winded answer, I know, but security is too often thought as an extra thing to add. Instead, it should be baked as part of our process from day one.
Okay. So let's imagine I have a DevOps environment,
Mhm.
and How can I test my DevOps environment against security threats or vulnerabilities?
I would say let's take a look. So if you have traditional CI/CD pipeline, right? So we start with an idea of a CI/CD pipeline. What we want to do is to run some of the jobs that we do in the same way that we always have, but then we want to add more things, making sure that we can make it secure. So your pipelines, your set of automations need to have more tools and more security, potentially based on conditions. So if we take a look at this sample pipeline, for example, so we have three stages. First stage is the build stage. Then you have a staging environment deployment, and eventually production environment deployment. Nothing different from what we know. Very common, fairly straightforward. Now, build stage. When it comes to build, the first thing that we should do is to check for credentials. Credentials in version control are always a problem because, again, once it's in there, it's in there. It's part of the history. So you should be able to prevent this from happening. And the best way for preventing it is making sure that a CI build, in this case on master, but it could be on a feature branch, it just fails if something is found. And that would be an excellent way of doing that. Following up from that, introducing something like SonarQube. So SonarQube will just run, and as you can see, all it requires is a little bit of preparation with a project name and with a connection, and that would be it. Then it would be taken care of by the server. Even better with Sonar Cloud, which is as a service. Then you go on and you run Beanskim, let's say. So you can target your DLLs, you can target your artifacts, your outputs, and you can just check with Beanskim whether you basically created or introduced any security problem, because Beanskim is going to scan your DLLs and outputs and checking them against a well-known set of security problems and vulnerability patterns. Once you're done with that, then you can check, for example, that your ARM templates are compliant and they are secure compared to the well-known standards and the standards that Microsoft devise. After that, software composition analysis, white source bolt. As we said, it's important to know what libraries we're using, what third-party libraries are in use, and what vulnerabilities are in there. And then a malware scan, simple, straightforward, but it is very, very handy. Reporting is important as well, but this is simple, right? This is just running a reporting tool. A reporting tool to create just a file that explains what happens. But in reality, adding these tools is not difficult either, because they are all available over here. So if you look at white source bolt, there it is. If you look at SonarQube or Sonar Cloud, again, here as well. So it's simple. Security doesn't have to be a burden. And the result of this is that when you go in a build pipeline, whatever that is, so we take a successful one, for example. This pipeline here is running with so many things. All right. So we have a SonarQube scan. We have a SonarQube scan. Then we've got software composition analysis. Then we have anti-malware scan, for example. Just a few things. But these make sure that you have things that can be actioned. So SonarQube, you have a dashboard. This dashboard will tell you, oh, look, you have 12 bugs because of reasons. So this one over here, remove this check because it will always be true. You want to use something else. This is something that a tool will scan your code with. The tool will analyze your code, and then it will report against it, also providing you with a potential solution. Or something like this. This was expecting a different code structure. Things like this, you might be writing code, you might have been writing code like that for a while. It might be right, but it might not be the best way of doing it. And having, again, tools that do this automatically, continuously as part of the DevOps workflow is extremely important. Then we look at software composition analysis. In this case, risk is very limited because I'm only using a handful of libraries, and most of the problems come from jQuery. This is an old, outdated version. But as you can see, white source, in terms of effort, adding white source, all it takes is one line over here. This is all you need to do. And again, I'm not simplifying or exaggerating, because if I add white source, I add this task, I don't do anything. I don't need to do anything because it is able to identify what's necessary in my code base. That's all I need. So it's very, very simple to include it. And if you do it, it's going to provide you with an out-of-the-box report with a vulnerability score that's going to tell you, look, you have security vulnerabilities that are well known, because those are CVEs, so they're fully well known. And it will tell you which library is a problem, and will also tell you what's the best way of fixing the problem. In this case, a simple update. You also have licensing scanning, because it might be a problem using a license that's got a certain type of license. So things like that will help you in understanding if you are if you're introducing a potential problem just by having the wrong type of license. And also it will provide you with a list of outdated libraries which do not have well-known security problems, but they're still old, and also a handy inventory, because more often than not, once we start adding external references and things like that, we lose control of what libraries we have in our pipelines. We lose control of what libraries we have in our applications, because anyway, there's always going to be Nugget or any other package manager taking care of that. And if the list becomes very long, it's also very easy to lose track of the potential issues. This is a small set of things that you can do. Then you can expand onto the environments. So again, back onto the various demos that we have at our disposal here. Checking an ARM template. This is key, okay? If you have infrastructure as code, you want to make sure that your template is secure. And this AZSK scanner is going to check for a list of well-known patterns in security for infrastructure as code. So things like using always deploying with the latest version rather than do not allowing HTTP access, or use a secure TLS version. Those are important things. And again, more often than not, they tend to be forgotten or left for the last minute. So if you introduce a check like this, you not only have a nice report that you can upload as a CSV file and whatnot, but you also have a nice way of understanding how many controls in this case are applied and how many of them have failed, and what's the ratio between medium, high, and low impact, for example. That's very important. But this is not just about infrastructure as code, because if you go on and let's say that you get to a point where infrastructure is good, then you might want to fail your deployment because, actually not this one, sorry. You might want to fail your deployment for reasons that are outside of your control. So over here, for example, we're waiting for it. Let's see if we have another ready-made one. Yes. So over here, we are failing our scan, but that's not because of ARM. That is because we are connecting to a certain environment that is already running, and it's telling me, look, you have these problems in your running environment. So someone might have changed things like, the IP-based access restriction rather than HTTPS being the only choice, or TLS has been reduced from 1.2 down to something else. The way that you do it, again, fairly simple. You need AZSK that's available on the Microsoft website, and then what you do is just running the security validation test. So you run against your Azure subscription, against a certain resource group name and a certain subscription ID. That's it. So you're targeting this resource group. Whatever is in there is going to be scanned. So if there is any diversion, you have the continuous assurance process that's going to check for the status of your environments, and it's going to stop you even before you get to a point of refreshing the environment with some new infrastructure as code. Because what would be the point of refreshing it if you already have a problem? If you don't know that you have a problem, better to raise it. All of these, as you can see, they can go behind parameters. So you might not need to run them all together, but you might need to selectively turn them on and off. That's another option. Obviously, on master, you should have as many things as possible, and all of them should be green. And in a development environment, you might want to hide them behind different configurations and different parameters. And that's something you can do easily with Azure pipelines. Eventually, you get into the realm of security testing. Sorry, wrong one. You get into the realm of security testing and stuff like OWASP Zap, brilliant, because it runs against your live application. It runs from a Docker container, so fully isolated, nothing to set up, very straightforward to do. And once everything is done, then you will have not only the list, obviously, of it, but you can also create a nice testing report. That's the way I do it. And there are, again, countless examples anywhere. But basically what you do is that over here in the test result, you will see that, okay, it failed because some tests have failed. Then you can go, ooh, not nice. You can get in here and you can see that, that's weird. But basically you will see the same results that you have here, okay? So some of the tests are passing, but some other tests have got warnings or problems, and those will be raised. In a nutshell, you can do so many things, and you have so many tools that you can use at your disposal. It's just about understanding what type of security you want to introduce, what degree of security you want to introduce, and also how easy it's going to be for you to accept the inevitable overhead that you will have at the beginning. Because adding all of these things, brilliant. But if it's going to stop CI, then you have a trade-off to make. So that's a question that you should always ask when it comes to introducing those tools. So it's the way that they will be introduced that's important to discuss, not the if, but the how.
Okay, great demo, by the way. Thank you. So I want to ask you add some tasks to YAML file, and I believe some of them is third-party tools. But I wonder how can Azure DevOps help to secure by environment by default?
So what you can do is add, for example, on a target environment, you can have validation and gates. So one of the things that I do in this demo, for example, is on my environments, in the production environment, what I'm going to check is for a number of conditions. So if I go into my approvals and check, I will have obviously a pre-deployment approval, usually by myself, because that's a demo. But I also want to make sure that I'm always deploying from master, because production should only go up from master. And then if you do this, you're already ensuring that anything that goes into prod has to go through the process of getting into master. If you have a consistent process, then what you do is pull requests with build validation and peer review, all sorts of things that are going to help you in having a secure and vetted code get into production. Then you have tools like the secure validation test that I mentioned. So if you get in here, you can look at it. What happens is that you go to azsk.azurewebsites.net and you just find the various AZSK tools. But in a nutshell, what you need is to validate for each deployment, for each environment, add this tool. It's called SBT or AZSK. Yeah, AZSK Security Validation, Security Verification Test. They are tools that are going to run against live environments. So your environment will continuously be validated and checked for these well-known patterns. So you can make sure that your target environment is secure.
Okay, thank you. So when we start, you show some slides and talk about STL.
Yep.
And when I'm googling on DevOps security, I have seen another term, OSA. So what are STL and OSA, and what is the difference?
SDL is something that happens over here in the development portion of the loop, and it is a methodology. So it's about developing with security in mind. So for example, in a requirement gathering section, as long as, well, obviously on top of getting all the requirements that you might have for a user story, you might also want to start building a threat analysis profile for that certain feature, so that you know what are going to be the weakest points in the chain and understanding where could be the places to secure. But it's also about understanding that security goes not just at tool level, but it's part of a methodology. So you have stuff like, again, threat analysis is a good one. You need to prevent your application from being vulnerable. And the best way of doing it is understanding where are going to be the problems. You will know that you will use, for example, a certain library or a certain, certain web application or database or whatnot. You need to make sure that things are secure. You need to understand how to attack your application before it gets built. OSA, on the other side, is a collection of patterns, practices, and in general actions that can be taken either as they are or as part of a bigger framework where you can improve the quality of your life cycle by adding those actions. So it's very similar in a sense, but OSA is more targeted towards the actions, while SDL is more about the broader methodology. So it's about having different layers of security baked into every portion of your methodology. So again, it's very similar, but there's a slightly different premise on there. The idea for both is actually to get to a point where you reduce cost, because at the end of this loop, you will realize that you always have a cost to fix bugs, and that cost is based on the time that you detect a problem. So if you identify a problem, especially if it's a security problem, right? So let's say, for the sake of the argument, credential leaking. If you identify credential leaking at architectural level, or even at coding level, right? You're coding the feature, you realize that things have been done the wrong way. This is going to cost exponentially less than finding out after release to production. Because if you have live users here and you realize that you have a credential leaking problem, SQL injection, you name it, okay, any type of problem, it's going to cost more because you have live users, you have something that's important for the business you're working for, you have the problem of protecting the existing data and the existing security. So fixing a problem in production, it's a degree of magnitude more complicated than fixing it even as part of integration testing. And this data is not something that I made up. This comes from the National Institute of Standards and Technology, and it is, I believe, is one of the most striking charts that you can see when you work in software development, because you never thought about what's the cost impact of a bug. And that's the cost impact. So it's just in front of you. You will be able to see that something, the later it goes into the life cycle, the worse it's going to be. So in order to prevent that, you can use the practices that we saw before and some other things, which we'll talk about in a few moments' time, that can help you out when it comes to working against those bugs. So again, rather than fixing them on the right, you try to shift left. You try to move everything towards the development side, reducing the cost and the effort required to fix those problems, and hence shipping software that's of a higher quality, that is generally better, and it's easier to maintain.
Okay, so for example, I'm developing a financial application, and my manager asked me to harden our DevOps environment. I mean more extra security. So are there any best practices for extra security should we do on Azure DevOps?
So using the security validation test that we saw before is an excellent starting point, because the Microsoft baseline is pretty strong, and there are so many recommendations that I've seen in a red state across so many years of experience. So it's always a good start. Well, other things that you can do, and they're fairly easy to do, is, generally speaking, writing better code and writing it with a secure mindset. So for example, talking about code, this is one of the simplest things that you can write. This is going to check the hash of a file name, right? Simple, straightforward. But as you can see here, MD5 is highlighted as a problem. That's because I installed DevSkim on my Visual Studio Code environment. So DevSkim will tell me, look, Matteo, this is going to work absolutely fine, but MD5 is a weak algorithm. So you should replace it with something stronger, with something better, that's more secure. And this is going to highlight directly in the IDE so that you will be able to replace it with something better. Even if you don't know about it, it will help you and it will guide you to do that. If you really, really want it, then you can obviously suppress the warning, but it will add a comment over here that you actually did that, because it's important that you are aware you are introducing a security problem here. So if you work with anything security, really, that's going to be critical, because you don't have to potentially think about what's the best way of doing it, but there's going to be something looking for you and telling you, look, this is not the best possible way. Just have a look here. You can use SHA 256 or 512, and you can find more information here about why we think it's important. So you have all the tools at your disposal to prevent, to inform yourself, and to fix. And another one that I mentioned before, it's about credential management. So in the CI/CD pipeline, we've got credential scanner. So this is going to check for any credential that's inside the version control system. There are well-known patterns for credentials and all sorts of strings that can be used for checking against usernames and passwords. But at the same time, it's also how you use those secrets. Because more often than not, when it comes to secrets, we are lazy. We tend to be lazy, and we try to make it as simple as possible without thinking about the consequences of doing that. So one of the things that you can do immediately is using a variable group. A variable group is a place where you can store your secrets. So your passwords, your usernames, all those things, they can be added over here, either backed by a key vault, like I do here. So I've got my key vault. I add everything in key vault. I'm not interested in knowing the secrets. Well, I mean, if I add it, yes. But if I'm a regular user, I'm not interested in knowing the key vault. All I know that inside the key variable, there is going to be a secret, and I can use it as a secret. If I'm not linking it with key vault, actually, let me get back to a new one. Let's create a new one, I would say. If I create a new variable group, then the difference is that if I don't link it, I will be able to encrypt it. So this is the value. But once it's encrypted, unless I think about it before saving, I can encrypt it and it's gone. No way to retrieve this anymore. The difference is that if you use key vault, you're using something that's obviously designed for handling secrets, and it's, I would say, not easier, but more appropriate. If you just need it on the fly, you don't need it backed by the key vault security, by hardware keys and whatnot. This is encrypted inside Azure DevOps, so it's very, very well safe as well. But again, it's up to the requirement at hand. In any case, once it's saved, the secret is not going to be retrieved. Also, for files, because if you use certificates or SSH keys, things like that, where you have private and public pair of keys, you might want to have a secure file that's encrypted. And using a library group and a secure file over here is going to be way better than actually storing them in file share or whatever. This is going to be encrypted anyway, so your secure file is going to be kept inside Azure DevOps in an encrypted space. That is so much better than having it anywhere else in the clear. Also, this is something that we can actually show on the fly. So I've got a script here. Okay, this pipeline, all it does is running a script. This script is very simple. I called it secret validation, because what I will do here is retrieving the secret from my variable group. There is always going to be a map between the variables that come from the key vault, the variables inside the variable group, and the general variables of Azure DevOps. So I will always have a $key variable available. What I did was writing a very simple PowerShell script that's going to check whether my input key that I passed to the script is equal to the control key. Straightforward, right? Simple. It's just string comparison. Well, at the same time, even if it's simple, it's also very secure, because the content of my secret is this is my key. So if I run this test with a control key of this is my key, this is obviously going to work. Actually, let me stop the other job, which, okay, it's fine. Let me just stop this job. We don't need that. Just, I wanted to do this, but it was taking too long. So I just showed you the actual outcome directly. So, is it stopped? Yes. Okay. So what's going to happen here is that my job is going to run, and it's going to run that script using my secret key as an input key, and this is my key as a control key. It's going to check the content of the two secrets, and it's going to tell me, yes, it's the same, no, it's not. But at the same time, you will never see what the secret is, because the secret is only handled by the agent in a secure way. So you see that it downloads the secrets from the key vault, and it maps a key variable to the key secret. Then it's going to check out my code, whatever. It's going to validate my key. All good here, all green. But all it says is your key, your input key matches the provided control key. You never see this. The input key is something that you cannot see. All right? Because you see, you can definitely see the PowerShell script. I'm not doing anything special to the PowerShell script. I'm not even saying that that's a secure string or anything like that. But then, if you run the same job with a different control key that is wrong and not correct, well, Azure DevOps is handling your secret. So Azure DevOps will know if you have the right value or not. And let's take a look at what's going to happen inside my job, because the execution is going to be exactly the same and the secret is going to be exactly the same. I only changed that parameter that's got a different value for the control key. And once it's done, my validate your key step, which is again plain PowerShell script, this is going to fail. There you go. In this case, it fails because it doesn't match the provided control key. Secret over here, control key available in the clear, no problem, but it's wrong. And we know it's wrong because it doesn't match what PowerShell is expecting. So the variable contains your secret, but you will not see your secret pass through in the clear anywhere. The only way for it to work is being passed wherever necessary by Azure DevOps, by an automation, by a script, anything. And that's going to prevent credential leaking. And it's extremely important to do that. All it takes, straightforward, you just create a variable group. That's all you need to do.
Okay, thank you. So, for example, I implement all the best practices for security. But what if I use a malicious container image? In short, what about container security?
Excellent question. So a container as is nothing different than any other artifact. So you have facilities that you can use, like the ACR tools, which, if I recall correctly, have got a container image scan. All the various registries have got a degree of scanning for security vulnerabilities. But when you run it, you need to make sure it comes from a reputable source. So either Docker Hub or anything that's got some, a reputation for being secure provider. You don't want to get a Docker image from somewhere which you don't know where it's coming from. You have no insurance about what's been done to it. And also it's important that when you build them, you scan your Docker images anyway, because you might never know what's going to end up into your code. The reason for that is that if you use any third-party library, you're always at risk of a supply chain security issue. So if jQuery tomorrow or any other library tomorrow will have some vulnerable code, you need to know about that, hence white source, and you need to be able to fix that. So if you continuously rescan your Docker images, that's going to be easier to fix rather than finding out after it goes into production. And as you container registry tools for Azure DevOps has got some tasks that help with that.
Thank you. So, this is my last question for today. So, are there any DevOps security challenges?
The challenge between DevOps and security is that even if as an industry we got to a point where we're pushing security towards developers, so you no longer have the team of the red team coming in, doing penetration testing, giving you a report and leaving for a year, leaving you to fix the bugs. So we're moving the problems towards the developers, meaning the developers are empowered to fix these problems as they come rather than wait for someone to raise them. But at the same time, if you are embracing those patterns and those practices, then you will have an overhead. You will have a slowdown in velocity. You will have the inevitable teething issues that introducing anything new into any environment will cause. So what I can definitely recommend is to start small and adding iteratively. So you start with, for example, let's say SonarQube. SonarQube is going to give you a nice dashboard about the state of your project, and it's going to tell you, look, you have an X amount of technical debt, you have these security hotspots over here, you have a number of code smells. So for example, if you look over here, security hotspots, those are places that regular expressions not being safe rather than anything else, or weak cryptography. So you need to make sure that you use a safe number generator rather than there are all sorts of things. And once you have these in place, so this is my end-to-end demo, bear in mind, is nothing more than the hello world with ASP.NET Core. Okay, so .NET New MVC is going to give you this. So knowing that with my hello world and the out-of-the-box set of quality rules from SonarQube, we've got 12 bugs, 49 security hotspots, 2 days in technical debt, and 195 code smells. That tells me that there is always something that we can do. And by adding just one minor change here, so adding SonarQube to your CI/CD process, you can immediately identify things. Then you can look into that and you can see that, okay, so this is Bootstrap. It's an external dependency. Fine. Bootstrap again, Bootstrap bundle.js, Bootstrap.js, and jQuery. Okay, so I don't have strong code bugs and strong code issues in my code base. Brilliant. Then you can go in there and start looking at the code smells. So references and pieces of code which are either unnecessary, complex and convoluted, or there are all sorts of standards around it. So for example here, this is a recommendation of adding a protected constructor or a static keyword to a class generation. It tells you why you should do that. And again, it tells you, look, you can do that. This is a code smell. This is not an issue per se, but it is a code smell. So it's something that it can be done better, more elegantly, and in a leaner way. Unnecessary using, so things that are not used. This is those references not used. Take them away, and things like that. So just by adding SonarQube, a simple tool like this with a scan on a hello world is going to identify all of this. So you can imagine that you start small, you add this, then you also add white source, for example. So you start doing software composition analysis. Oh, jQuery is out of date in my hello world. Let me update that. Oh, Bootstrap is out of date. Let me update that. And you will slowly go up towards a better place in terms of security because you are addressing those problems at the source rather than once they actually become problems in production. That's what you should always remember, I would say, as the biggest security challenge, balancing the impact with the overhead.
Okay, thank you very much. That was a great presentation. Many
Thank
thanks to you and our audience. So while we are waiting any questions from audience, do you have something to add before we finish?
Well, I would say that it's important to actually start doing those things as soon as possible, even if it's just, again, scanning the code base, not doing anything, but it helps you understanding what's the scope, what's the degree of magnitude that you're looking at. Because think about it, hello world, 12 bugs, 49 hotspots, and 2 days of technical debt. This is for a hello world. Can you imagine a code base with a few years, a few years of history, maybe passed through different teams, or with multiple teams contributing to the same code base? Problems will quickly escalate. So once you have that, identify what's really, really important for the business, start fixing, and iterate on that. So having those tools fully automated in the CI/CD pipeline, they are going to uncover something that seems overwhelming at the beginning, but it doesn't mean that you need to stop. You have to stop working on new features and fix everything beforehand. It's important to bake this into the process continuously, so we have continuous integration, continuous delivery, and continuous assurance. This is very, very important, and it's something that more development teams are doing by the day, likely.
Okay. So thank you very much, and hopefully see you in another episode next year.
Anytime. Cheers.
Okay. Thank you.
Bye.
Cheers. Bye.
Bye bye.